The figure of the rosette shown over is subject to a transformation in the following order. Axial symmetry in the line QR, this line here. Translation equal to QR, so every point will move the same distance and direction of that line, and central symmetry in the point S. So a completed drawing is going to look like this. So axial symmetry in the line QR, so every line is taken at 90 degrees across the line QR, that's our axis of symmetry. Translation equal to QR, so every point is moved this direction and this distance. And central symmetry in the point S, from here, central symmetry through the point S. So the first section, axial symmetry in the line QR. So we're going to take each line 90 degrees to the line QR, lightly across, so they're construction lines. And step each distance the same distance on the opposite side of our axis of symmetry, which in this case happens to be the line QR. That's going to be my new point A. Point B. Point F. Point T. Point C. And point E. Okay, it's extremely important that we index each of these points the same way. So my new point A, I'm going to index point A1, point B1, point F1, P1, C1, and E1. So I'm going to start off. My circle is going to be the same size in every view. So I can set my radius on my circle. From my new point A, I'm going to draw in that circle. So I'm going to join up the points in the same order. So point B is joined to point C. So I'm going to join B to C. C is joined to D. D to E. And E back to point F. So that answers the first part of my question. Axial symmetry in the line QR. The line QR being my axis of symmetry. The second part of this question, he asks us to do a translation equal to QR. So I'm going to translate or move each point this direction and this distance. So to do that, I'm going to line up my set square with the line QR, and sliding that on top of my second set square, I'm going to transfer each point down that direction lightly, again, as these are construction lines. And along each of those lines, I'm going to set the distance QR using my compass, and I'm going to mark that length along each line. Point A, point F, point B, point D, point E, point C. Making sure to index each of my points and join them up in the same order. This is now A2, F2, E2, D2, D2, and C2. And again, joining them up in the same order. So E is joined to D, B to C, E to F, B to C, and radius of this. So that's a translation equal to QR. So every point is moved this direction and this distance also. The last part of our question asks us to find central symmetry in the point S. So for central symmetry, I join each point through the point of symmetry, which in this case is point S, and mark the same distance on the opposite side of the line. So again, very likely as their construction lines, join each point through the point of symmetry, point S, and mark the same distance on the opposite side of the line. Setting my compass at S, I start with the smallest distance, B, A, and F, D, and D, point C. Again, indexing my points become the point C3, D3, D3, A3, B3, F3. And joining my points in the same order again, C to D, D to E, E to F, B to C,